Hello, everybody. How are we enjoying reInvent? Good? Woo! So we're here today to talk a little bit about growing to full suite observability with Elasticsearch and the ELK Stack. I've got my good friend John here to talk about his experience with doing this at Dish. Do you want to introduce yourself a little bit, John?
Absolutely. So my name is John Haskell, go by JT if you ever see me online. I am the head of engineering for Dish Media. We are a subsidiary of Dish Network, so some of you might have heard of us. Got a team of engineers, and I've been with the company for about 14 years, and I actually started at Dish just as a system administrator, taking care of servers and being a ticket runner, like many of us have started in our life. And as of today, taking care of all the engineering firms for anything that is commercial insertion.
Fantastic. Thanks, John. And I'm David Hope, and I bet you can't guess where I'm from. Buffalo, New York, that's right. So I'm obviously not originally from there, but I moved over there about 6 years ago, so in the Niagara Falls area. I've been doing customer-facing work my whole career, so I was a consultant in the UK, I was a customer of APM, of AppDynamics actually at the time, moved over to the US, became a solution architect at AppDynamics. So pretty familiar with the observability space and particularly APM. So let's get started. John, do you want to just talk through a little bit about what Dish does? I think they probably all know what Elastic does and probably heard enough about that, so.
Yeah, so Dish Media is actually a newer department for Dish Network. We've only been doing business for 12-ish years. When I first started at Dish, there wasn't a such thing as Dish Media. And so anyone who's watched TV or live television has seen plenty of advertisements, and I'm sorry, that's us. So the commercials that you see on a day-to-day basis is what we specialize in. We do a lot of different things with the linear advertising business, and then as of the last 7 years, we've worked with some great partners over the years and created an awesome addressable platform. And so my specific team's responsibilities is to develop, test, implement, and as well as maintain all of these platforms that produce these wonderful commercials for everyone to see. Currently, we're making about $1 billion of revenue annually for my team, which is about $115,000 an hour. So as you can hear, reliability is very key for me. If I go down for an hour, you see the revenue loss that we actually lose. Currently, as of today, we play about 120 unique commercials out to consumers a day. And what these unique commercials do is they target you as an individual based on interests. And it's a wonderful platform.
So we're going to talk a little bit today about the journey that John's gone on, and it's going to be a similar journey to that you will go on if you decide to implement full suite observability. Now, first of all, we're going to talk a little bit about the challenges. You know, what problems are we trying to solve? Why would we even start on this journey to full suite observability? And then we're going to talk a little bit about John's requirements for an observability solution. What is it that Dish needed to be part of this solution? And then we're going to go step by step through the full journey from nothing to full suite observability. So what are the challenges that everybody's facing at the moment? I think one of the big things that everybody's talking about is this explosion of data. And there are very few platforms out there that can actually handle the kinds of data that are being generated on a daily basis. Luckily, you're in good company because Elasticsearch is one of those platforms that can handle enormous volumes of data. So it's perfectly placed to deal with observability data as well, because if you think about it, observability data quite often is many multiples more than the normal data about people or about things that go through your system. The observability data that is monitoring all your systems or observing all your systems is vast. So, John, I'd love to hear from your perspective about your data challenges and how Dish has ended up with so much data and what you're doing about that.
Absolutely. Let me paint a picture for you. So at Dish Media, we have to go through a whole series of data before we can even play one commercial out. So the first thing that we end up doing is we're collecting data. We collect vast amounts of data of all viewership information throughout the field. This could be your viewership information, such as which channels do you prefer to watch. This could be likes on social media. This could be any kind of data, including credit card information and credit information and what purchases you've made in the past. And once we have all these data points, we will then collect the data points and we have to scrub the data. So this sounds dangerous, right? We have a lot of data, we've got tons of information, we've categorized you as an individual. We now have to scrub it for PII data, for personal identifiable information. And so once we do this, we can tokenize the data and kind of generify the data to the point that we can then categorize our audiences. Maybe you like EV vehicles. Maybe someone over here would like 4x4 trucks. We have to categorize all these data points into categories that we can then bring back to the marketers and sell this inventory space. Advertisers then will view you as a consumer and play commercials that are more toward your liking. This helps a lot, so that way you're not watching diaper commercials when you don't have any kids in the house. It helps a lot with making sure that you as a consumer see the advertisements that you would actually be interested in. Once all this is done, we then will actually play out the commercials to our audiences, and then the data will come back, and this data is vast. There's tons of data that comes back. We will then have to analyze it, correlate it, and then reanalyze this all over again for the next campaign. So, as David said before, we have tons of data. It keeps growing every day. When I first started with this whole platform, we were 4 engineers. We were tiny. And as of today, we have now over 100 people working in the Dish Media environment doing the same work that the 4 people did in the past, because the data's just grown that vast. We now do over 10 billion records a day from the field from 25 million different device endpoints out in the field. Those devices could be anything from your Xbox to your streaming stick to a Dish Network set-top box. So let me take you back and tell you the story before observability. Many of you probably actually feel this way today in your current day-to-day business. We were a very reactive business. We waited for the phone to ring, and then we tried to figure out what the problem was and how to fix it. Before, we had about only 15,000 data points on site. We were only monitoring a very small, slim piece of our business due to the fact is we didn't have the employees or the systems to handle such a large data set. We had a tool for every problem under the sun. If I wanted to know where my performance metrics for my servers were, I had a tool. If I wanted to know if a server had a bad hard drive, I had a tool. If I wanted to know anything from the field, from a device, I had yet another tool. So as you can hear, I had a lot of data coming in, and I had to look at different tools to correlate that data. Now, anyone knows if you have multiple tools to correlate data, they don't talk to each other. So you, as the engineer, or as a business analyst, will have to then determine where this data is coming from, how to correlate the data, and what's actually happening in the field. And this took time, way too much time. So we had limited bandwidth, we only had so many heads. There was 4 of us at the beginning, lots of late night calls. It's a lot of fun being those guys. We had no insights. We had nothing going on, anything that was happening. So anytime there was an issue, it was a reactive approach. It was the issue happened, what happened, and how do we fix it? Meanwhile, there was a negative impact. The business was losing money. We didn't know it. We were losing money. So that created a lot of challenges for us, and we needed a solution.
Yeah, I've been there myself, John. When I worked at HSBC, trying to find a problem is like trying to find a needle in a haystack. Absolutely. With all that data, and trying to answer a question and being able to answer it in one place without having to tie all these different data sources together. It's tough, right? Well, let's take a little look at the requirements that you had, right, for a solution. So take it away. Let's have a look at these, right?
Has any of you out there made a business requirements doc, BRD? Those are fun, right? You get everyone on this round table, everyone's throwing ideas, you're building tons of ideas, like, oh, I would love it to have this feature, and it needs to have that feature. And before you know it, you've got project sprawl, right? We've got so many features, we don't even know which ones we actually wanted to go for. This happened to us, to the point that we finally just closed the doors, made a think tank, and had 5 executives in a room and said, all right, out of each one of your teams, what is the problem that you have? What is the top problem that if you could fix tomorrow, what would it be? And they were able to bring up a small group of requirements. And these requirements were first and foremost, our engineers are tired. We did not want them to work harder than they needed to be. So we needed a way to take some of the load off the engineers, take away some of those incidents that were happening on the day-to-day of hours, if not days, of research, and let them look at innovation and look at the horizon. The second thing is, we were tired of having 50 different tools for every solution under the sun. So we needed to consolidate into a single pane of glass. And that was a huge point of view. And that was harder than it sounded like at first. We then needed to find a way to take all the data and all the processes and try to bring it into our system near real time, as much as we can get as close to the play out as possible. As soon as that commercial happens on the customer, I want to know, did it play? Was the customer satisfied with it? Did they skip it? Did they change the channel? Did anything happen that was weird, like macro blocking or anything wrong with the video quality itself? I needed to know that data as soon as possible so I could fix the problem before the customer got upset and called the call center. Next, we needed to go through something that was more flexible. Anytime the business needed a report, they would pick up the phone, call the developers and say, hey, I need a report that says X. Developers go, okay, I'll make you a report that says X. They present the report, took them a week to program it out, and the business says, oh, I didn't really mean it that way. I need it a different way. Developer says, okay, well, let me go do that for you. Another week passed, right? So our reporting was slow, very, very slow. And so we needed something that would provide flexible reporting that would take the developer's time away from that and actually let the business analysts and the project managers be able to build their own reports with minimal effort. The other thing we had to do, we were all reactive. How do you look at the future if you're always looking at the past? So we had to find a way to look at forecasting, tracking, and baselining our systems. And then finally, as much as a lot of us think machine learning is a buzzword out there, we needed to find a way to start looking at outliers, a way to automate our system, and the way to take that tier 1 level support and make it obsolete so they can also focus on looking at the future. Yep.
I love it.
And so something came new about this. Everyone in the business side, we do everything on a KPI, a key performance indicator. Everything has to look better than the year before. Well, something that we were able to put together with this is operational and business never talked. And there was always times that the operational departments would affect the businesses, or the business could affect the operational team. And they had no way to correlate the data. So with the new system, we needed to be able to bring all that data into a single pane and actually correlate that data into something that is easily accessible. And then something that COVID brought, unfortunately, fortunately, we're now a hybrid cloud. Before COVID, we were 100% on-prem. We didn't even think about going to AWS. It's not the case today. We're now into a hybrid model, and so now we needed to think about the system of, well, how do we monitor a hybrid model? Do I now need yet another set of tools to monitor the cloud as well as my on-prem systems? Or can I find a tool that would do both? And so many of these options that you see on the screen are something that everyone has to deal with on a day-to-day basis, and we needed a solution. So,
what's the solution, eh?
I wonder what it is.
So I think, John's talked about a lot of interesting things there. Major challenges with the amount of data that their customers are producing. We saw that at the beginning there, advertising, personal adverts, targeted advertising is generating a lot of data in itself. And then having that data coupled with the operational data about how the adverts are performing, how the systems serving the adverts are performing, all of the operational data is another problem, right? It's another huge amount of data that you have to deal with. Elastic can actually deal with both. So it's dealing with some of the business data and the operational data, and it can tie it together, which is great. So that helps you with some of your requirements there, right? There's also machine learning, anomaly detection that they needed solutions for. Things were taking weeks, is what we heard, right? Things were taking weeks. And I think we're down to days or even less now, right? With
Sometimes
the
on the same call.
On the same call. I love it. I think that's what you were telling me earlier, right? You were saying to me, you could be on a call with a senior executive, they'll ask some kind of question, ask the question inside the system, and it comes back with an answer super fast, and then they'll be like, oh, no, I need something a little different. But you can still do it all in the same conversation, which is huge. You haven't got to go and set a developer off to go and build a project for 2 weeks to answer that question anymore. Now, Elastic's an interesting solution because a lot of people think that it's just logs and search. That's what we're famous for. But we aren't, right? The reality is we have a whole new cast of characters that you can see on the screen here. You'll see Loggy there. That's the Logstash mascot, by the way. Handsome chap. But as you can see, right, he's only one part now of the solution. We've now got APM, which Gartner says is a top 3 APM solution in the marketplace for most persona workloads. We've got infrastructure monitoring, synthetics, RUM, and universal profiling now all in the box there. So this is not just a logging solution or a search solution anymore. It is a full suite observability solution. So how are we going to use this to meet the goals that John set out there? We're going to go through various steps. The first thing we need to do is ingest and centralize all the data that's out there. How are we going to do that? Tell us your story, John. How did you tackle this problem?
So a lot of this data that you see here is something that we all deal with on a day-to-day basis, right? We deal with a ton of vendors, a ton of different pieces of software, and this is just a very small list, but this is pretty standard for a lot of companies now. Now, between this list, we've got some cloud services, we have some on-prem services, and each one brings its operational challenge. So one of the things that we had to think about is how do we get each one of these pieces of data into a centralized system? And what was great about the scenario here is Elastic Observability was able to provide us multiple options. There were times where just a simple fleet agent would take all the data that we need and bring it into the system. There were times we could do a quick SNMP walk, everyone's done SNMP, and bring all that data into the system. And then there was also times that was so unique to our business that no one else had that system out there, but we were able to write a quick script with Python to data map it and bring it into Elastic. So as we were going through all of the centralizing of data, we were trying to figure out where are we going to find it all, where are we going to see it, and no matter how hard you try at the beginning, you never know 100% of your data, right? So you'll be going through it, and your exec will come to you and ask you a question, and you're like, you know what, I've never thought about it that way. So we were trying to find a way to get every bit of the data in the raw into a system so we didn't have summarized data. We didn't have data that was sitting there that wasn't going to be usable in the future. So we were looking at the ingest pipelines. So at Dish, we have mobile devices, about 8 million of them. We've got Sling accounts, about 3 million people using Sling accounts. And then we have about 12 million households with just various set-top boxes. Now, the various set-top boxes were probably the easiest for us. It's the low-hanging fruit. We control those. We can easily get that data. But how do you control the data from somebody's cell phone? How do you control the data from a mobile app that's sitting on an Android device? You have to be able to get all these data from all these different data points and find a way to get it through. Now, APIs were our best friends, absolutely. But at the same time, we needed all these different ingest pipelines from Python to using an API call to dealing with flat files even. Still to this day, we're going to have some flat files that come back because one of the biggest challenges that we have at Dish Network is our set-top boxes are one-way communication. We're a satellite company. They don't talk back. We can send you information, and then we have to wait for a call back. If you guys never call back, I never hear from you. I don't know what's happening. I can't help you. And so that information has to come back in a near real-time presence. And as we all transition to internet-connected devices, this is becoming less and less of a challenge. But at the same time, we're not like other companies who have two-way communication. If you have internet-connected devices, you can always get two-way communication, right? Versus we have to send a command and wait for a response.
So what you're going to want to do in your own environments, for everybody in the audience essentially, is you'll want to install Elastic agents to collect all of this data. Now, we used to have this legacy way of doing things where we used to install file beats, metric beats, all kinds of different beats and things like that. We don't need to do that anymore. We actually transitioned over to what we call the Elastic agent, which is just one single unified install that you can install on your systems, and it'll give you all the visibility you need. I think, John, you've been going through this transition from what we see there to this Elastic agent using Fleet as well, right, to manage the agents that are out there. So we have a management facility called Fleet as well that allows you to upgrade and manage the lifecycle of Elastic agents. How's that gone for you?
It's a night and day difference. Before we were just static to have all the data in a single instance. Now that we have the Fleet agent, that took even more work off of our engineers. No longer do they have to go out there and update all these agents or push out new software. They automatically update. So if we want to push a new config file, we can log into Elastic and actually control our fleet with a couple clicks of a mouse. It's wonderful.
That's great. And Elastic Agent will even work with cloud environments. So it can pull data from all these different AWS services that you see on the screen there, but it's not limited to that. We've got thousands of integrations that you can use to grab data from anywhere, really. So you have CloudWatch and CloudTrail on there, and you can even send that data in via various different methods, but the Elastic Agent can handle the input of that data and send it over to Elasticsearch. The only thing that's not yet in the Elastic Agent install is our APM. So for the time being, if you want traces and metrics, which you obviously do with a full suite observability solution, you're either going to have to use the Elastic APM auto instrumentation, the agents that we have, the proprietary agents we have, or you can start to look at open telemetry and Jaeger and things like that. And I think, honestly, that is where the industry is going. Open standards, open technology. We're actually, I looked at a GigaOM survey there was the other day, and it said that we're one of the best vendors for completeness of a solution for open telemetry ingestion. Mm-hmm. So I think everybody needs to start thinking about this. People need to start thinking about open telemetry. They need to start putting the code in their applications to start utilizing open telemetry. It's definitely the future. There are so many use cases that you could potentially look at once you open up those that data feed, right? It's no longer a proprietary data feed of telemetry data. All of a sudden, other applications and other use cases are going to pop up, things that want to automate your environments, things that do AI ops, not just APM anymore. If you open it up, anything can get to that data and start to do useful things with it, right? The great thing is that in Kibana, you just go into Kibana and it will tell you, depending on which language runtime you have, you click on a button, it'll tell you how to set that up, and it'll also give you instructions for setting up open telemetry as well. So we've got all this data, we pulled it all in. Well, hey, but it doesn't mean anything yet, right? We need to generate some insights. We need to actually understand that data. We need to make sense of it. Mm-hmm. So John, tell us a little bit about what you did at Dish with once you had all this data inside Elastic.
Having data at your fingertips is nice, but if you can't make sense of it, what good is it, right? So what was really great about doing this is we were now able to correlate data across different actions. We were able to take even a single set-top box. For instance, this is a set-top box in Ohio that's one of our developers. This is his dashboard, probably about 2 months ago, and it showed us when he was playing out commercials throughout a week. It told us where he was located, told us if there was any errors on the machine, told us if the hard drive was healthy. It told us a whole bunch of different insights that we could have on a very easily based. And so what was great about this was before, I would have to talk to all those 6 different managers I was talking before to even get each one of these pieces of information. And now, a call center agent can even pull this up and say, oh, okay, well, your set-top box looks like it's doing okay, or it's doing bad, or I foresee this already having a bad hard drive. Let me get you, like, when was a good time to roll a truck, and I can get you a new set-top box tomorrow. It's something that we can now be on the proactive approach. And it's a very different way of doing business. So I want to show you a good example of one of the things the execs have asked us in the past. And it started with just an easy question, a very easy question. We would just like to know the density of our customers across the country. Sound like a very simple thing to do. Before observability, it wasn't so easy. Before observability, what we would have to do is find a flat file of those customers. We would then have to have some kind of geographical information, whether or not a zip code, lat long, something to be able to track where these customers are physically located. And a lot of times it could even just be a DMA. So a lot of things with DMAs are they're markets that are addressed with a number assigned to them from Nielsen and other companies. And we would take this data, we would then use an open source tool or some kind of tool like Google Maps to try to map this data for our execs, which then gave us a static map. The execs can then use that static map to answer their questions. But the only problem was the data was only good for the time that we ingested the data. If the question ever changed, oh wait, I don't want the density of every customer. I want to know the density of a customer who has a Boost phone and a Dish account. Okay. Now we got to go find that data set, merge them, find a way to bring it all together, and present that data. And this took time, again. So we were looking for a single tool, something that could be instantly available. And it's happened many times where we were able to take that data and show the execs exactly what was happening. And while we're on the call, we could do a working call with the execs and make that data instantly available. They're like, oh, I want to see that filter. You add a filter. 5 seconds later, the data's up on the screen again. It's very fast. And that's something that we were able to ask a question, get an answer.
So you talked a little bit there about the bespoke dashboards you built. You can put business operational KPIs on that dashboard. You know, there's some custom monitoring that you've been able to do there, which would be difficult if it wasn't such an open platform. This dashboard is one that we put together at Elastic, and it tries to show the same thing, right? You can see it may be a bit small where you are, but you can see the number of ads that are being served. You can see the revenue that's being produced by the adverts. There's a grid at the bottom there which shows which services have anomalies from a machine learning point of view. And then you can see the health of the system and what it's like to experience across the whole world, right? So this is for an e-commerce website. So, you know, if I'm in Russia, it doesn't look like the experience on that website is particularly good. So you can see all kinds of useful information here from the business, from your operational data, all together in the same place. And it's queryable too, right? So the great thing about Elastic is that you can go and find Elasticsearch box and start to query for any piece of data in there, right? Doesn't matter whether it's traces or metrics even, or logs, or custom data that you might be sending in to do monitoring with. People talk about observability like it's 3 pillars. I think I'm reading blog articles coming out every week that adds another letter, but it's kind of missing the point. If it's useful to help you answer questions about what your infrastructure and your applications are doing, then it's observability data, right? We don't need any more blog posts with another letter. It's all good. So, you know, machine learning has had a bad rep in the observability space, I think. I used to work partly at AppDynamics, and a lot of times what happens is, and the reason it gets a bad rep, is because, you know, a vendor will create a model and they'll hide it behind the scenes somewhere. You won't be able to see the model, you won't know what the model's doing. The vendor's going to assure you that that is a really cool algorithm that they've produced, and, you know, it's proprietary, couldn't possibly tell you what's happening there, but, you know, some geeks in the back end, they created something cool. Trust me, I've seen algorithms that were described exactly like that were terrible, all right? So, you know, And then also they'll layer on this like magic genie on top that pops up and says, hey, you've got a problem. But it only can find like 5 different things, right? So we've taken a different approach, right? With Elastic, we've made our platform available so that you have machine learning algorithms and you can actually go and see those machine learning algorithms. You can see the jobs that are running those machine learning algorithms. You can see some of the configuration that's gone into those machine learning algorithms. You can run those machine learning algorithms on any piece of data in Elastic. It doesn't matter whether it's security data, doesn't matter whether it's observability data, doesn't matter whether it's custom business data. You can run those machine learning algorithms on any piece of data in Elastic. And you can also bring your own machine learning models. So if you've got some folks that you've probably got data science teams out there, they probably generated some pretty interesting models. They can bring those to Elastic and run it on the data that is inside Elastic. Mm-hmm. So yeah, a much more open approach to machine learning. Let you look at the models, inspect the models, bring your own models. And I have a funny story about this. I actually worked at DataRobot for a little while, which is a machine learning platform, which you may not know. And a sales rep from DataRobot rings me up and he says, I'm working with this customer and they're telling us that we're competing with Elastic. Now, Elastic is not a machine learning platform, but I think it speaks volumes that we were able to solve problems that they were also trying to solve with DataRobot with Elastic. And so these are all the different things that you can bring to the table with Elastic Machine Learning. You can do supervised algorithms, unsupervised, you can do forecasting and anomaly detection, you do classification on log files, you can predict quantities with regression. So, really is very extensive, almost could be considered a machine learning platform in itself. So John, tell us how you've been using the power of Elastic Machine Learning at Dish.
Our environment is very unique, as I said before. People's viewership habits change on a day-to-day basis. There could have been a football game or something in that city that day, and for some reason, just less people were watching TV. So before, to create outliers and threshold numbers were almost impossible for us because the numbers were never the same. They were always, today they're 2 million, tomorrow they might be 14 million. It was really hard. So we were able to then start doing outlier detection and correlation models. We could take all the data points that we have, bring them into a single model, and then actually look for those outliers. And wanted to give a story of where we actually used this about, a month and a half ago? A month and a half ago, we used this when the hurricane was hitting Florida, the first one. Was it the first one? It was pretty bad. So there was a lot of people who depend on their dish system for their emergency broadcast systems. There is a lot of people who use our systems for multiple reasons. It could even be the Boost cell phone itself. Everyone's gotten an emergency alert on their cell phone as it went off. We have to make sure all of those function to the best of our ability. But again, we're a satellite company. So how do I make sure that signal can punch through a hurricane? It doesn't matter how much power you send up on a satellite, it's not going to punch through that cloud. So we were able to use outlier and anomaly detection to notice that all the set-top boxes in the field were starting to drop with their signal strengths. Their signal strengths were starting to go lower and lower pretty quickly. And to the fact that before the customers even picked up the phone, we were able to switch satellites of where the signal's coming from natively without the customers even knowing it's happening. And so we were able to react upon that before the customer even knew there was going to be an issue. And we weren't able to get 100%. I mean, sorry, hurricane's pretty large, but we were able to get about an 80% of the customers brought back into normal signal range and still have their signal in the middle of a hurricane storm, which is pretty crazy. And so now we use machine learning for multiple objects, and one of them is going to be forecasting. Forecasting allows us now to look at the horizon, know where our platform architecture is struggling, where we're underutilizing our platform, or even where we can now budget for the future. When that exec calls you up and says, I want to sign another customer, can we do it? Now I can actually tell them yes. Before it was, let me look into the system, let me find out where we're sitting, and I'll get back to you. And it would take us sometimes days to get back to them just to make sure that if they throw an extra, 1,000 commercials onto the platform, that it doesn't bring the whole thing down to its knees. And so we're able to now use forecasting. It's wonderful. And it's one of those things that before I would have never been able to do. Before it was, I looked at the data, I think we're okay. And so what do? We threw more hardware at it. That's all we did. We just kept throwing hardware at it. Well, we're to the point now, I can't just keep throwing hardware at a solution. We're to the point where if I throw more hardware at it, my AWS bill is going to go way up, right? I need to utilize the hardware that I have and make sure that I'm utilizing everything perfectly. And then it also helped us in the long run for next year's budget. And when I'm asking for more hardware, I can tell them, here it is, here's the graphs, here's what we need, here's what we project. In 6 months, we're going to be out of space. So if you don't get us hardware, we can't grow the platform any further. So it's been, again, a proactive approach compared to where we used to be.
I love that story about the hurricane. I think that's fun. That's really awesome. So just to finish up, we can apply our machine learning to any piece of data that comes into Elastic. And so here's an example where we've got a revenue spike, right? So remember we were talking a little bit about an e-commerce platform. Imagine we've got an e-commerce platform and our customer decides to buy thousands of pairs of leather pants. I don't pass any judgment on that. You buy that if you want, but it actually possibly might have been a mistake, right? So there's a spike in revenue there. Leather pants are expensive, and so maybe we might go back to the customer and say, hey, was this a mistake? But also, it works the other way around, right? If the revenue drops to zero and there's nothing coming through your e-commerce website for any kind of reason, the anomaly detection engine will automatically tell you that that has become a problem. Now, the thing about machine learning, which it doesn't really show so well on here, is that over a long time frame, if you're all sitting around looking at dashboards that have static thresholds, there are so many things you can miss. So one of the solution architects at Elastic came from E-Trade, and one of the things that he used to do was he would look at any dashboard that people were looking at, and he would say, we're just going to get rid of that dashboard and replace it with machine learning, because there's no point human beings sitting there trying to see the wood from the trees on a dashboard when a machine learning algorithm can do a much, much better job. So the last step that we're going to go through is we're going to talk a little bit about automation and then security as well. So the final step here, or the final piece of the puzzle, is to make sure that from an observability perspective, you want to start monitoring your dev tools and your DevOps tools. So I think Elastic contributed quite a lot of code to Jenkins to enable it to work with OpenTelemetry. So if you have Jenkins in your environment, you can now use the OpenTelemetry plugins to start monitoring your Jenkins environments. So start to monitor the tooling that produces your code. Why not? Make sure that your infrastructure of code tools, right, your DevOps tools, make sure they're integrating observability into everything that goes out of the door. And then finally, and this is more of a process thing, a business thing, start thinking about observability earlier on in the dev cycle. Shift left the requirements for observability. So when you're actually developing a use case with your business, start to ask them and start to think about what are they going to want to know about the functionality and how it's performing. And do that before you start writing the code for the main piece of functionality. That way you can start to make use of the OpenTelemetry APIs, and you can start to put tracing code up front in your application before you do it after it's gone to production or something, right? Now, I know you had a good experience here with your CI/CD processes, right, John? So do you want to tell them a little bit about that?
So CI/CD is nothing new in the industry. Anyone who does development work probably have a CI/CD pipeline. I hope you do, unless you're one of those who test in production. I mean, no judgment. But at Dish Media, one of the big things that we used to do was test for functionality. We would write some code, put it in the dev. It works, okay, let's push it to test. It functionally works, right? The customer gets the commercial they're looking for. The customer gets the new app on their set-top box or whatever it may be. And then we would just say, okay, functionally it works, let's push it out to the field. And we were cautious about it because we know it worked on the developer's laptop. how well that works sometimes. We knew it worked in our small test environment with our 10 set-top boxes, but the moment we push it out to all 12 million households, is it going to break something? Is there something that we didn't think about? And so what we were able to do is then take Elastic Observability and add it into our pipelines. And now, not only are we testing functionality, we're testing performance metrics. We're making sure that that extra code that we didn't throw into the system slowed it down. Our goal is to always go a tad bit faster, right? Always go faster. Mainly due to the fact is the hardware's not going to get any faster on a set-top box. If I throw another thing on the set-top box, is the customer now going to have a bad viewing experience? And so what we had to do is we had to start thinking it from the very beginning. Let's add all of these different performance metrics and tests and baselines from the very beginning. Go from your dev environment before it goes to your test, before it goes to production. And it has saved us a lot of heartaches. And I used to say rollbacks are one of those things of life in IT, and unfortunately, I actually disagree nowadays. It used to be, it was a thing. Rollbacks are a thing. There was a chance. There's always a chance. The IT guy always said, it should work. He never said it will work. He said it should work, right? And so anytime, he always gave the back door a way out so he could roll back. With this, we haven't had to roll back pretty much since we've started. And it's great because now anytime we find a unique use case, we can build it into our test plans now and actually keep looking at all the metrics and not just some of the metrics.
Bring it in earlier. I like it. And security. You've done a bit of stuff with the security as well in Elastic, right?
Was a part of our BRD initially. It really wasn't. It was actually one of those cool extra features. And we've grown to love it. And so Elastic Security gives us the ability with the same fleet agents that we have on our systems to do a ton of security checking that we weren't able to do before. Now, it complements everything of our current security practices, but it also helps us keep a closer eye on our systems. No, we can see who's accessing the system, locations. We can look at process management. We can take baselines now of our system, and anytime a new service or a new process just shows up on a machine, I instantly know about it. I can make sure that those insider threats are kind of taken care of because I can see all the admin commands that are being ran and who's logging in at what time. And if anything falls in an anomaly, again, remember machine learning, we can actually make machine learning algorithms to say, if there's something that falls out of this range, please let me know about it. Log4j, right? That's always a fun one. Log4j was one of them that we used it for. We could easily search our entire platform and be like, no, we're good. Right? Or, oh, there's 2 outliers. Let's get those patched real quick and we're good to go, right? It's pretty easy, especially on those zero-day attacks. And then the final thing is we were able to do this in the cloud as well as on-prem, so we were able to make sure we do some of the policy management from AWS and do all the same thing we're doing on the site, but in the cloud as well. And then finally, we were able to add a whole bunch of integrations. David's not wrong. There's 1.5 million integrations. Some of them, I don't even know what they are. But the community makes integrations. Elastic makes integrations. There's integrations for everything. And sometimes other partners will make their integrations for Elastic. And that's what we did. Is so now we can see our IOCs. We can see our indicators of compromise, right? We can actually complement our rapid scans and our threat protection scans and actually see this all in real time. And as I said, this was not part of our BRD at all. It just ended up being one of those happy bonuses that we use now every day.
I like what you told me earlier, right, with this. So John was telling me that, the security team, they're always on everybody's case, right? So they call up the teams at Dish, and most teams at Dish are scrambling around like, oh, I don't know whether there's like a vulnerability here or not, but they call up John. John already knows. Yeah. He's on the ball.
Yeah. Any of you have the naughty list from a security team? Like you're like, hey, are you patched? You're on the naughty list, and now you're over here following, like every day they're calling you, hey, are you patched yet? Are you patched yet? Right? And that's something that helped us with it, because as soon as it became an IOC, well, as soon as I could actually see the actual threat, it told me instantly what patch I needed to apply, and then we would just go do it. Which saves, again, my tier 1 support no longer really are tier 1, because the day-to-day monitoring, they don't have to do anymore. They're doing the work almost like a tier 2, because now they can follow up with these patches. They can follow up with these things that happen almost in real time, because when those 0 days hit, you've got to get them patched. There's no time to wait around, right?
So that completes the journey. So just to recap, right, we talked about the challenges that we're all facing out there in the world. We talked about the requirements that Dish had for a solution. And then we went through the steps, right? Ingesting all the data, creating actionable insights, leveraging machine learning, automating all the stuff and securing it, and making sure that you're doing observability earlier in your dev cycle. So we just wanted to leave you with some tips. So John, you had some great tips as you went through this journey, some little gotchas and some recommendations, right? So take it away.
Yeah, so we went through all of this, right? Before observability, we were very reactive, we were slow. This is nothing new. A lot of people are like this. If you have too much data, what do? You take a sample size. You look at 10% of your data. You look at something smaller, something you can ingest, right? Now we can do everything that we went through on this presentation. Let's go to the next slide. So what I want to leave you with is the don'ts and the do's. Something that we learned through the process, it was a learning process, don't get me wrong, is for one, don't ignore cleaning your data. The data set itself is just as important as ingesting all the data in the first place. If you have corrupt data, if you have data that doesn't really make a lot of sense, maybe it makes sense to the engineer, but doesn't make sense to the business analyst, this is your chance to understand your data and to enrich your data. This is your chance to say that 0, 1, or 2 that the engineer says, oh, I know what that is. The business guy says, well, 0 is a success, 1's a warning, 2's a failure. That's what he's looking for. He doesn't want to have a lookup sheet. So clean your data. Make sure that you don't work on your entire data set all at once. It's a daunting task to begin with. So try to find where would you get the most benefit and start with that first. Don't work independently. So Elastic's been a great partner with us. When we first started, we actually started back in the days of the ELK Stack. We started with the community edition. It was free, it was wonderful. It didn't have all the bells and whistles, but it was cool. And then when we went to the enterprise version, we were able to then work with Elastic, and they've been a great help. We were able to get them training for my developers and speed up that process quite a bit. And then don't forget how your data is going to be used. Just because it's data, make sure you can actually think of an idea how you would use it. Because the more that you know about your data, the more that you can say correlations, the more it's going to make sense in the long run. Elastic makes it a real easy case to bring all that data into data views, is what they call them. And you can bring cross data views all into a single picture and present correlations and pictures that you've never seen before. Make sure that you start with a small footprint. Always start small. And then try to find a way to put it into your CI/CD pipeline. Find a way to bring it into your test cases. And yeah, it's great. And we like to look at the bottom right corner. You see operational and business. It's never was a thing before. The operational teams and the engineering teams and the business teams never knew how to work hand in hand. And now we can present views to them that the business team can see how they can interfere with the operations team and vice versa.
I think that's crucial, right? Bringing business and operational stuff together, and that helps you with insights and about what's going wrong with your systems, right? I think you can't really get a good grasp on it without both. I like this which you've got on here, which is find the small wins. I get a lot of questions from customers on this, which is, how do I get to full suite observability when I've got, stuff over here with one vendor, stuff over here with another vendor, different teams, different things. You've got to take the small wins in that case, right? So one of the things that Elastic does is our APM is free, right? You can go and download it, and you can install it on smaller apps. If you've got smaller apps out there that haven't got any APM, get APM on them. Why not? It's free. It's free. Just start trying to progress slowly. Nobody is, I don't think anybody out there is, certainly not many people out there that are in the position of just whacking full stack observability into their environment. So you've got to start slowly and incrementally start to move things in. And as soon as you do that, you'll start to benefit from all this consolidation and all this data being in the same place. and asking questions without having to run around 5 different teams. But it has to be done slowly. So, you know, if you've got Elastic for logs, and you've got another team over here for APM, just start to trickle feed Elastic APM to these folks, right? You know, maybe they've got some dissatisfaction with their current APM, or maybe they just want something that's more consolidated. I think, you know, you've got to start small. You can't boil the ocean here. Mm-hmm. So Elastic's got some tips for you here too, right? So one of the things that I highly recommend is, in order to break silos, you'll find that Elastic will end up with a lot of data, and people, you know, that doesn't have to be prohibitively expensive. We now have searchable snapshots and data tiering. And I have heard recently that our slowest data tier, or our most cost-effective data tier, is much, much faster than even some other folks' warmer or even hot tiers. So just because the data is in a slower tier of storage does not mean it's going to massively slow you down to the point where it's unusable. So you definitely should be using data tiers to keep your costs down. Open first, you know, I talked a bit about this. Open telemetry is the future. You really need to start to think about how that is going to change your business. Throw out proprietary, you know, methods of transferring observability data. Don't do that anymore. Start to think open first. And, you know, you may even consider an observability pipeline or something to collect the data so that you can have multiple consumers of that data off of it. You know, something like, I don't know, Kafka or Pulsar or something like that might be a good observability pipeline to implement. Use machine learning on all of your data. You know, this is what I was showing you earlier with the machine learning stuff, right? Any piece of data that you have in Elastic, you can use machine learning for. So do it, right? You can, if you want to forecast something or do anomaly detection, that's really easy to do and really easy to start with. And finally, use the full suite, right? You know, use the APM, the logs, the metrics, and the security that John talked about. That way, you're going to get a much better chance of being able to get answers to the questions that you're asking of your systems and your applications. Thank you very much, everybody. It's been a pleasure. Cool.
Thank you.